So one of the more defining features of water is that it's a polar molecule, and this means that one part of the molecule has a positive charge while the other has a negative charge. Now you know the formula for water is H2O, so there's an O for oxygen. On the periodic table, oxygen has 8 protons, and also means it has 8 electrons. And therefore they kind of cancel out and you have no charge. I'm going to draw the 8 electrons of oxygen. There's going to be 2 electrons in level 1 and 6 electrons in the second level. Now water is also made from hydrogen atoms, and so I'm going to add 2 hydrogen atoms. Hydrogen has 1 proton in its nucleus and then 1 electron in its outer level. So by themselves, all 3 of these atoms are unstable, but they also have no charge, all 3 of them. However, when water forms, the 2 hydrogens will bond with the oxygen. So now that the atoms have bonded, let's focus our attention on the red oxygen atom. What we're going to see is that it really hogs the blue electrons of hydrogen. Let me go ahead and put the red electrons in motion. And what happens is the oxygen atom will actually kind of take the blue hydrogen electrons. And by doing so, this is how oxygen becomes negatively charged. It has 8 protons, but it has 10 electrons, giving it a negative charge. And this is how the blue hydrogen atoms become positively charged. The blue hydrogens still have their 1 proton, but they don't have any electrons, making them positive. And you can see we've fulfilled the definition of what it means to be polar. 1 part positive, 1 part negative. So let me freeze the electrons and remind us that a covalent bond is when the involved atoms share electrons. An ionic bond is where one atom takes electrons from another. You might think this is an ionic bond because it looks like oxygen is taking electrons from the hydrogen atoms. However, we're going to see it's a covalent bond because every now and then a couple of electrons will orbit around the hydrogen on the right, and every now and then a couple electrons will orbit around the hydrogens on the left. But most of the time the electrons are orbiting around the oxygen. So the definition of covalent bonds is fulfilled because they do share electrons, it's just not shared equally. So here's a simpler picture of a water molecule bonding with another water molecule, and they bond by what's called a hydrogen bond here. You see why they bond. Positive hydrogen is attracted to negative oxygens, and when we add more water molecules, you can see a bunch of hydrogen bonds are forming, which hold polar water molecules together. So here's a layer of water molecules, and what's underneath them are more water molecules, again positive connected to negatives. And what's underneath layer number 2 is layer number 3. Underneath layer 3, well, it depends on how deep the water is, but notice how the molecules are arranged positive to negative because water is polar. So because water is polar, there's a few other characteristics. One being that water has a high specific heat. And what this means is that it will resist changing temperatures. It's not impossible to change the temperature of water. You can boil it, of course. It just takes a lot of energy to break the hydrogen bonds. So here's a pot filled with water. And if we add a flame underneath, over time, what happens is these hydrogen bonds begin to be broken and the water begins to evaporate. But because water has a high specific heat, it just takes a lot of energy to break these bonds. Eventually they're broken and the water evaporates. So this is actually a really good thing, water having a high specific heat, because this helps to maintain our constant internal body temperature. You know, the mass of our bodies is mostly water. And even during strenuous activity like the athletes in this picture, our body temperature hardly changes. We've all had moments where we've had a fever and we felt miserable and we've been ill and sick and we don't feel very well. Well, what's going on there? Well, when our normal body temperature of 98.6 degrees Fahrenheit, well, we have proteins in our body. And here's a protein X. But in an elevated temperature, the protein begins to denature and unravel. And so when our body temperature becomes too high or too low, proteins within our body start to break down, and therefore our cells lose the ability to perform whatever function those proteins are responsible for, and it could lead to some of the ill effects that we feel when we're sick. So maintaining a constant internal body temperature is really important. It's a good thing. We're mostly made from water. So another characteristic of water is that it has cohesion. And because water is polar, it will be attracted to other water molecules that are also polar. You know, the paperclip that you see in this picture, it's not actually floating. Let's explore this. So here's water, and let me add a paperclip. And if I were to ask, why is this paperclip able to stay atop the water? It's not that really that it's floating. It's just that the paperclip isn't heavy enough to break those hydrogen bonds that we talked about earlier that are connecting one water molecule with another water molecule. For the same reason that you see in this picture, water strider are insects that can skip across the surface of water here. You can actually see where the legs of the insect come in contact with the water. The water is kind of flexing and bending underneath the weight of the insect. The insect is just not heavy enough to break those hydrogen bonds. But because water is polar, it will attract with other water molecules, and that's what cohesion means. So because water is polar, it also has adhesion, and this is where polar water molecules are attracted to substances other than water. Here's a graduated cylinder filled with water. Notice the curvature right there. That's known as the meniscus when you add water into a graduated cylinder. Now the bottom of the meniscus might read 25 milliliters and the top might read, let's say, 29. Well, how much water is inside of this graduated cylinder? Do you read the top or the bottom? In order to be accurate, you always read the bottom of the meniscus, 25 milliliters. But the point is, why is there a meniscus in the first place? Well, that's because water is polar and it's attracted to the inside of the graduated cylinder. Again, this is just another good example of how water has adhesion.
Molecules such as water, which have separated positive and negative charge centers, are said to be polar molecules. These polar molecules demonstrate attraction towards electric charges, as can be seen here when a positively charged glass rod is moved close to the stream of water.
So changing topics, I want to mention that water is one part of a solution. You might know a solution is simply a mixture where one substance can dissolve within another. Now solutions tend to have two parts to them. One part being a solvent, and this is going to be the watery part. So the solvent is the part of a solution that actually causes things to dissolve, and the things that dissolve are called solutes. We'll talk about them in a moment. And water is typically the universal solvent. And the other part of a solution are called the solutes that I just mentioned a moment ago. Solutes are the parts that actually dissolve. And so if you put sugars into water, the sugars are going to dissolve. Salts will dissolve when you put them in water. Nutrients will dissolve when you put them in water. So here's a beaker of water. Let me add some sugar and some maybe strawberry Kool-Aid powder. And which makes sense? Statement A, sugar dissolves in water, or B, water dissolves in sugar. Statement A should make sense. The sugar in the Kool-Aid is going to dissolve within the water because the sugar are the solutes. The Kool-Aid is the solutes and the water is the solvent. So a great example of a biological solution is blood. Now here's a test tube filled with blood and there's a stopper on top, and if we put it in a centrifuge, which is a machine that spins it really fast, it will separate into these layers. The bottom layer being red blood cells, the middle layer being white blood cells and platelets, and the beige liquid on top, this is blood plasma. Plasma, which is mostly made up of water. That makes plasma the solvent portion of a solution, and suspended within that plasma are solutes, such as sugars and proteins and salts. So blood, again, just a really nice example of a biological solution made up of solutes and solvent.